Like everybody else, when I got the mission, I got out my crystal ball, the same one that John got out, to try and look into the future and see what everything's all about, but then I tripped, and that was that. So my predictive abilities are going to be really not great today. Instead, I'm going to talk about sort of a wish list of things that I would like to see happen in the next 50 years. And like other people have mentioned, this is mainly for the students in the audience because they will be training the students who are in 2060. So when I think about what I want, I usually don't go straight into technology, although I would still like a lot faster operating system and a lot more storage and things like that. But a lot of times when I think about the future, I end up thinking about the past and what I miss that used to be around. And so I'll talk about a few of those things today. We're psychophysiologists. What do? We data process, we data reduce, we clean, we code, we merge, we average, we look at data constantly all day long. And I was fortunate to start psychophysiology where I didn't have to do it on paper because I don't think I would have lasted very long. I started with the PDT-11 25 years ago in Peter Lang's lab. And there were things that were problematic about data processing in those days, but there were things that were quite efficient about it as well. So for instance, I was talking to Ed Cook the other day, and he had written a small graphics interface for the PDT-11 where I could churn out thousands and thousands of graphs in about an hour. It would produce the graphs. It took a little while to print them. And as we both noticed, they looked pretty lousy. But in terms of the processing power, compared to now where you have to point and click, click, click. Now my graph programs, many of them want me to be there every minute with them for every graph. And I find that really inefficient and sort of, unreasonable. A lot of the software is written by computer people who don't actually do data processing all day. And I think if you sat them down and said, use this program and for 8 hours, they would say, I can't, it's horrible. So I do think that in terms of some of the processing ability of the old mainframes, that we've kind of lost a lot, and I'd like to get back to something like that. Secondly, in terms of software, I'll find a program eventually that seems pretty good, and then it starts upgrading, and each upgrade is worse than the one before, until the program is completely unusable. And I've had some interesting conversations with software people about this, where I call, and the first thing they say to me is, you really have to be willing to move on. Like I'm an old-fashioned person. I don't want new software. I said I'm happy to move on, but I don't want to move backwards. And I think that happens a lot. And the third thing that happens is I find a good program and it totally disappears and you can never use it again. The operating system changes. It's no longer, it needs something that's not available. So these are things where the past has been good and the present is getting less good. So when I think about this in terms of SPR's future, I think we should take some of our money and build a software platform that we develop for data reduction and analysis. Using our knowledge, we're the best, I think, the best data people in the world. We know the problems, we know what we need to do with it, and we're trying to do it, with all this other software that other people have developed that aren't psychophysiologists. So I would like to see SPR get its brain together and its computing and programming abilities. Our students still learn programming the minute they get into the lab, and they're good programmers. And let's make something that we can use, that gets better, and that eventually the whole world is using because it's the best data reduction software around. So in terms of technology, that's where I would like to see SPR go in the future. Second issue that I think about that comes up is just basically the science of psychophysiology. And of course, we're a society that's in a community of psychological science with a lot of other societies around. And so the way we do our science is influenced by the way we think about it, but also by the way the community thinks about it. And it's not just the psychological community, it's also the wider science community. So we're operating in a climate where physicists and chemists and biologists and archaeologists and all sorts of people are doing science. And the current thinking about science changes over time. And when I started, and I was on, grant review committees and doing a lot of reviewing for journals and things, the good thing was programmatic. People say, this is programmatic research, this is good. What they meant was it was focused, it was systematic, it was comprehensive in that it took into account past data and looked towards the future, and replication and extension was its main methodology. So each time you replicated what you'd gotten before, and then you extended it a little bit. And that was how we sort of plodded along. Now, this is called incremental research. And usually people say this with a sneer. So you'll be in grant reviews or get a letter from an editor and they'll say, this is really incremental science, I really can't publish it. And it's a total, switch from looking at something that was programmatic and now became something sort of negative. And the new wave is, these are illustrated by the NIH grant application criteria, is to be novel, to be innovative, and to be significant. So that instead of thinking about programmatic research, we're supposed to be now operating in a mode where everything's novel, innovative, and significant. We're breaking barriers, we're blasting through old concepts, we're developing new approaches, new methodologies, technologies, tools, and we are. We have always developed new technologies, methodologies, and tools. Science cannot develop without that. But does it happen in an explosion in one afternoon? No. Usually it happens after a long, a lot of work developing a paradigm, understanding your measure, getting the right data, and that sort of thing. So this is the present, I think, in terms of the way people are thinking about science. And I think this occurs both in the grant world and the journal world. And I'm afraid for the students who think that this is the way science develops, that every idea is new, it has no connection to anything else, and it's highly significant. And I thought, why have we gone this route all of a sudden? I mean, programmatic was good for a while, and of course, things change, and that's cool, but if you think about it, I presume, although I will be interested in why other people think these criteria become current, I think there's a lot more people doing science right now. There's a lot more papers being published. I think the emphasis on quantity of publications has even gotten published and perish was always a big deal, but now it's crazy. Now you put in a first-year graduate student NRSA and they say his publication list isn't good enough. It's gotten really nuts. So everyone's got to publish and publish. So papers are pouring out. There's thousands of more journals. There's online journals. There's stuff everywhere. There's experiments everywhere. There's data everywhere. And I think at some point people are like, what are we going to do with all this stuff? We can't manage it. So I think the idea was to only get breakthroughs. So everything else you sort of work on, maybe in your own private lab, but what you really present to the world for funding is breakthroughs. And I just don't think that that's the way science proceeds. We do it slowly and we do it incrementally. I think John Cacioppo has the right answer that when you have more people, you need teams. And teams make things go faster. Because if you're working by yourself for 40 years, you won't get as far as if you're working with 40 or 50 people. So I think the answer is to develop teams that are working on the same questions, and that's how we can make progress. I don't think, though, that this emphasis on novelty is going to get us somewhere. And this is a couple of pitfalls, I think, of this approach. When people are forced to be novel, they have to ignore the past database. Because if you mention somebody did something that's related to what you did, they're going to say, this isn't novel, this has been done before. So first of all, ignore all the past data, because that's dangerous. The second thing is it's got to be innovative. So you certainly do not want to replicate. I mean, replication would be death. So don't do anything that anyone ever did before, because that's going to not get you anywhere. And thirdly, significant. It forces claims that this is rocket science, this is great. I mean, I have made a major breakthrough, and I don't know if I've ever made a major breakthrough, but to have to claim it every day is more than I can do. And I don't think, again, it's good for students to think they have to do it. How are they going to be, coming up with something significant starting out in their careers? They're going to have to build slowly and get there. So to sort of reinforce this, because this is just all me going blah, 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 I called on some great scientists from the past. And of course, Isaac Newton was not afraid to look at the past database. His science was built on the science that went before him, and I think psychophysiology has a lot of good science. I mean, you go back to Lacey and Obrist and Graham and all those folks, they worked out a lot of the basic problems in psychophysiology that I don't think people really are aware of necessarily, that could help them in their current research. But you don't want to know about it because then it seems to be discouraging. So I would say, don't be afraid to use the past data and to build your experiments on that, because you'll get somewhere faster, and if somebody doesn't like it, we'll talk about that later. Second person is Pavlov, and this is up into my lab. It's a really nice piece on science from Pavlov. And the first thing he says about science is gradualness. It is not breakthrough. He says gradualness, gradualness, gradualness. And I love the fact that he says, I can never speak without emotion about this most important condition. So if you think that's the way science proceeds, you can be much more comfortable doing it than when you think you have to have something novel and innovative every time you walk out the door. And the second person, who I think is a great scientist, who has a very nice paper, I think, on similar theme, is Peter Lang, and who taught me most of what I know about science. But he also says here that replication really is our basic fundamental building block. And right now, I think there's a lot of one-offs. There's people do things and they publish it, it's novel and it's innovative, but you don't know if it replicates and nobody ever tries. So we can't build, we don't know what's reliable and what we can count on. So replication is something that is still good, and I think, as reviewers, when people do replicate, instead of saying, this has already been done before, we can say, this is good, you replicated this effect, I feel more confident, and then move on. And finally, Pavlov went back to modesty as the second most important scientific principle. And this is the sense that, yes, we can claim things are highly significant and they're going to change the world, but really, we're mostly modest in our claims about what we can do, what kind of progress we make. And so to require people to be immodest, I think, is doing science a disfavor. So in terms of SPR, I think these things are pendulum. We might be in novelty now. We'll probably swing back to programmatic. But for SPR and SPR members, I think we can carry the ideas that replication is good, that looking at the past data is good, and that being modest is okay into the world. We're reviewers. We're people that are active in the scientific community. We don't have to take it. And I think that a lot of these things I've said today are really taking things I've liked from the past into the future. Thank you.